Proxima B, a world of shadows and fire. A transmission echoes from the fathomless void. A signal, an anomaly, possibly artificial, possibly natural, or something else entirely. It leads us to a world that challenges every assumption we've ever made about life in the universe. A desperate dash toward another star begins. What if everything we've believed about the cosmos, about habitability, stability, and life, stands on the brink of collapse? Enter the James Webb Space Telescope, JWST. A marvel of human ingenuity, orbiting 1 million miles from Earth. It peers deeper into space than any instrument before it, revealing galaxies that existed mere hundreds of millions of years after the Big Bang. And now, it has turned its gaze toward something far closer, and possibly far more significant. Meet Proxima B, an exoplanet orbiting the red dwarf star Proxima Centauri, located just 4.24 light-years away, a cosmic stone's throw in astronomical terms. Since its discovery in 2013, Proxima B has fascinated astronomers, but for years, we could only guess at what this distant world might truly be like. Until now. With JWST's cutting-edge infrared capabilities, astronomers are finally able to study Proxima B's atmosphere, surface characteristics, and potential habitability in rich detail. And what they've discovered is, quite simply, breathtaking. Proxima B orbits alarmingly close to its parent star, just 7.3 million kilometers away. That's less than 5% of the Earth-Sun distance. The planet completes a full orbit in just 11.2 Earth days. This close orbit has dire consequences. Proxima Centauri, unlike our relatively docile Sun, is a highly volatile red dwarf. It experiences frequent and powerful stellar flares, violent bursts of electromagnetic energy that can have devastating effects on surrounding planets. In fact, a flare observed in April 2021 was 100 times more intense than anything ever recorded from our Sun. If Proxima B once had an atmosphere, it may have been stripped away by repeated flaring events. Yet, Proxima B refuses to be easily categorized. JWST has provided the most detailed imagery and data to date, revealing that Proxima B is likely a rocky planet, with a mass about 30% greater than Earth's. This suggests a stronger surface gravity, which could affect everything from atmospheric retention to the flow of water, if any exists. But perhaps the most fascinating, and disturbing, aspect of Proxima B is that it is tidally locked. This means one hemisphere of the planet is permanently turned toward the star, experiencing eternal daylight. The other side remains in endless night. Imagine a world divided in two: on one side, relentless radiation and scorching temperatures under an unsetting sun. On the other, a freezing abyss locked in eternal darkness. But what if there's more to this twilight realm? Between the burning light and the frozen dark lies a narrow ring of eternal dusk, the Terminator Zone, or Twilight Belt, where temperatures may be just right for liquid water to exist. Could this be the planet's last refuge for life? This twilight region, a sliver of habitability on an otherwise hostile world, has become a prime candidate in the search for extraterrestrial biology. Some scientists even speculate about subsurface oceans, much like those beneath the icy crusts of Europa or Enceladus in our own solar system. These oceans, potentially warmed by tidal heating or a hot planetary core, could harbor environments shielded from the star's deadly radiation. If life exists on Proxima B, it would need to be extraordinarily resilient. Perhaps adapted to intense radiation, extreme temperatures, and limited energy. Much like extremophiles on Earth, organisms that thrive in boiling hydrothermal vents, acidic lakes, or the vacuum of space. Could life on Proxima B follow a similar path? Or would it be entirely alien, based on biochemistries we have yet to imagine? While the potential is thrilling, the dangers are overwhelming. JWST has captured unmistakable evidence of ongoing high-energy bombardment from Proxima Centauri. Without a thick atmosphere or strong magnetic field, Proxima B would be left exposed to cosmic fury. And yet, there remains a possibility. A thin veil of heavy gases, such as nitrogen or carbon dioxide, might still cling to the planet, offering some level of shielding from radiation. Could Proxima B have a magnetosphere? Could its core generate a protective magnetic field, like Earth's? Some models suggest it's possible, though not certain. And if true, it could drastically improve the planet's chances of retaining an atmosphere, even in the face of such a turbulent parent star. Still, JWST's findings paint a sobering picture. Proxima B may not be a second Earth. But it might still hold the building blocks of life, or a completely different form of life altogether. What we've learned so far has only deepened the mystery and raised new questions about what it truly means for a planet to be habitable. But the story doesn't end here. The next phase in our journey toward Proxima B isn't just about observing it from afar. The race to Proxima, and the question of first contact as our telescopes sharpen their gaze on Proxima B. Humanity is already preparing for the next great leap, to physically reach another star system. At the forefront of this ambition is the Breakthrough Starshot Initiative. Led by a team of world-renowned scientists and backed by figures like Stephen Hawking and Yuri Milner, this ambitious project proposes sending ultra-light spacecraft, no bigger than a postage stamp, to Proxima Centauri at speeds approaching 20% the speed of light. Powered by ground-based lasers, these starchips could travel the 4.2 light-years to Proxima Centauri in just over 20 years. If successful, it would mark humanity's first interstellar voyage. These spacecraft would carry cameras, sensors, and communication systems. Not humans, not yet. But the implications are no less historic. For the first time, we would be sending artificial emissaries, built on Earth, to another star. And this effort leads to even more provocative questions. What if we receive a signal before we arrive? What if the anomaly we once dismissed as background noise is not random? What if someone, or something, is trying to talk to us? Should we respond? Should we send a message to Proxima Centauri? The possibility of intelligent life beyond Earth has long been the stuff of dreams, myths, and science fiction. But increasingly, it's becoming a scientific question, one that might soon be answered not with speculation, but with data. And if Proxima B does harbor life, microbial or advanced, how would that change everything we think we know about our place in the cosmos? The implications are staggering. We've long searched for another Earth, but Proxima B may force us to consider that life doesn't require Earth-like conditions. That life might exist in radiation-scorched deserts, beneath frozen crusts, or in atmospheres toxic to humans. We may need to expand our definition of life itself. And perhaps that's the most important lesson Proxima B offers. That the universe isn't built for our comfort, but life might still find a way to survive in its harshest corners. Even if Proxima B turns out to be lifeless, studying it will help us understand how planets evolve, how atmospheres are formed, or destroyed, and how stars shape the destiny of the worlds around them. And perhaps, it will help us understand how rare, or common, life truly is. The race to explore Proxima B is no longer just a dream. It's a global mission pursued by NASA, the European Space Agency, private ventures like SpaceX, and research collectives around the world. And this is just the beginning. In the coming decades, we may map its surface in detail, determine whether it has weather, oceans, or even signs of biological activity. We may learn that Proxima B is utterly hostile and barren. Or we may glimpse the first faint signs of alien biology. Either way, our understanding of the cosmos will be forever changed. So the question remains, should we send a message? Should we break the cosmic silence and say, we are here? Proxima B could be a beacon of hope, or a warning of what lies ahead. Whatever awaits us there, life, death, or the infinite unknown, one thing is certain. The next chapter of humanity's journey has already begun. And it may lead us to the most profound discovery of all, that we are not